Now it's time to teach you how to gamble. So there's these things called, yeah, now he's paying attention. Okay, so there's these things called a fair gamble, which basically means that the expected value of taking this gamble is 0. So if you did this a whole bunch of times, you wouldn't win anything, you wouldn't lose anything because it'll average out to 0. If someone is risk averse, they will not do a fair gamble. If they're risk neutral, they'll be like, I don't care. But if they're risk preferring, they will always choose to take this fair gamble. And you can kind of judge these risk curves based on this thing called utility, which basically like how much enjoyment do you get from having a certain amount of money. So if I were to risk a certain amount of money, but I could win a lot of money, that's kind of judging the difference in utility. And one thing to keep in mind is most people will take small gambles, but won't want to do will take these small gambles, but are a bit more averse in kind of these larger gambles, just because it's so much money that they could be losing. And so if you have a linear risk curve or a utility curve, that means that it's risk neutral. If it's smiley face, so if it goes like this way, so it kind of curves upward, then they're going to be risk preferring. And then if it's concave, so kind of down, then it's going to be risk adverse, which we'll get to. Okay, so your expected utility of a gamble, basically similar to expected value, just with one more extra step, because why not? So you're going to have your gamble, 2 outcomes of your wealth. You're going to take the outcome of this wealth, apply a formula to it. That's your utility formula. Multiply that by the probability of this outcome. Do that with the other outcome. You take your wealth in this outcome, put it through the utility function, multiply it by the probability. You add those two together, and then that's going to be your expected utility of this. So that's the expected utility of that gamble. And then if you take that combined expected utility and you put it through the reverse of the utility function, that's going to be your certainty equivalent. It's going to say, how much money would you rather have for sure than taking this gamble? And then the difference between the expected value or the expected value of your wealth and the certainty equivalent is going to be your risk premium. So just graphically, we're showing here. So again, this is the concave risk utility function. So this someone is risk adverse. The gamble line is below the curve here. And so if we look just on the curve here, so we know that this is where our wealth starts at. And then we could get our wealth to that level if we lose the gamble, or W4 if we win the gamble. And then we kind of go up to our utility function and say, okay, that's the utility of our wealth here. That's the utility of our wealth here. And then you take the difference between your expected value for a fair gamble, which would be 0, and then your certainty equivalent. And that gives you the risk premium, which is just kind of visualized on the graph here. And just one thing to kind of keep in mind here is your people who are risk adverse would rather have something for sure. People who are risk averse have a risk premium because they would rather have a smaller value for sure than risking their wealth for something. And that's why there exists a risk premium, and you calculate that based on the expected value minus the certainty equivalent, which is like, okay, this gamble is worth this amount of enjoyment to me based on how we calculated it, but what amount of cash for sure is also worth that same amount of enjoyment to me? That's the certainty equivalent. Okay, so we learned about gambling. Now let's learn about insurance. Essentially, it's the opposite of gambling. Now, risk adverse people would be willing to pay more than the fair value of insurance, kind of the opposite of their risk premium, because it protects their assets, because it helps them through losses. So if something is actually fair insurance, then the cost of the insurance is essentially going to be equal, or the price of the insurance is essentially going to be equal to the probability of something bad happening times the cost of that something bad happening. And then people who are risk adverse are going to want to pay more for that. And that's essentially how insurance companies make their money. And that's why they want to purchase it, to avoid these potential losses. Speaking of losses, there's a little potential clown here, but framing matters in how you kind of state losses and gains. And then so people are normally risk adverse when making choices involving gains, but then risk preferring make choices involving like avoiding losses. So depending on how you frame a certain question, even though mathematically it'll be the same, they'll make different decisions or different choices because of that. So if I could gamble to try to save a lot of people, save them from dying, I would want to do that, and it just kind of the psychology of how you state the phrase changes people's reaction to it, which is just important to note and keep in mind. And then similar to framing is the prospect theory, which basically says that $1 and $2 is a bigger difference than $1,001 and $1,002. So you kind of have this reference point. So here we have kind of gains on the top and losses on the bottom left, and then you see how the curves kind of flatten out. This is basically saying that as you kind of get more and more wealth or more and more losses, the difference between a $1 or $2 becomes less and less, because your reference point is much different. It's out of that steep range, and then your risk preferring kind of in the domain of losses, because you kind of see it's like the opposite concavity.